Hello there, this is Josephine. You're welcome to the channel. Today we are going to look at dimensional analysis part 1. Previously, I solved problem on dimensional analysis and how we can use it to find the values of constants x, y, and z. So today I want to look at another part of dimensional analysis where you can find the relationship between two variables connecting together. So let's look at this question on the board. The velocity v of a wave in a stretched string depends on the tension T in the spring and mass per unit length mu of the spring. Obtain an expression for V in terms of T and mu using the method of dimension. Now, looking at this particular question, they want us to bring or come up with a relationship connecting the V, which is velocity, and the tension, which is a force, then the mass per unit length, which is mu. Okay, so the first thing we are going to do in order to get this thing right is for us to state the relationship between them. Okay, so if we say that the V, which is velocity, is directly proportional to what? To the tension and to the mass per unit length, which is what? Mu. Is that okay? And don't forget that in any proportionality sign in physics, you must introduce a constant. That constant might even be dimensionless, but let's just be that we have what? A constant. So if you remove this, you introduce a constant by saying V is equals to kt and what? Mu. You get it now? Mu. Do you get it now? So the next thing we are going to do is to introduce a variable for like a power. Introduce power to each of them. So we have, I can say this is power x and this is power what? Y. So we have to find the powers x and y so it can help us to get the relationship between. If you are joining this channel for the first time, thank you for stopping by, and I assure you you won't regret joining this channel because it's the best place to be and you eliminate the phobia in having understanding physics. So let's solve for the values of x and y. Stay tuned. Let's solve this together. We have that v is equals to k t, you say raised to power x, then mu, you say raised to power what? Y. Okay, so what we are going to do is to know what this stands for, this stands for, and this stands for, and that settles it. So k is equals to velocity, and the unit of velocity is meters per second. Then the dimension is lt minus 1. Okay, then t is tension, and tension is a force. Unit is kilogram meters per second square. Then the dimension is mlt minus 2. All right, mu is mass per unit length. Okay, which is mass over length, and the unit is what? Kilogram per meter. Then the dimension will be ml minus 1. Then k is a constant, which is what? It is dimensionless. So it does not have dimension. So let's substitute it in what we have. So when we have v, remember that v is equals to, we can say ktx mu y. So my v is what? Lt minus 1, okay, is equals to k. What is my t, which is tension? mlt minus 2 all power x. Okay, what is my mu? I have ml minus 1 all power y. So let's open the bracket. I have lt minus 1 is equals to k. Okay, I will have, this is m power x dot l power x dot t power 2x, okay, in bracket. Then this is what? Y power m power y dot l power minus what? Y. Alright, let's open the bracket. What do we have? We have lt minus 1 is equals to k, okay. We open it to have mx dot l power x dot t power minus 2, sorry, minus 2x, okay, dot m power y dot l power minus y. Okay, so the next thing I'm going to do is to bring them together, collection of like terms, okay. So I have lt minus 1 is equals to k bracket. We have m here, we have m, so let's bring them together. I have mx dot my, okay, then dot l power x dot l power minus 2y minus y, sorry, okay, dot t power minus 2 what? X. Is that okay? Alright, so we can also add them. lt minus 1 is equals to, this is bracket, k bracket mx plus y dot lx minus y dot t minus 2x. So the next thing we are going to do now is to relate this side to this side, because we already have lt minus 1, okay. Now since we don't have m, automatically we can say that we can put m and raise to the power of what? 0, okay. We can put m and raise to the power of what? 0, because anything raised to the power of 0 is equals to 1. Then this L that we already have, it has an invisible power of 1 from the law of indices. So this is 1. Is that okay? So let's relate them together. I can start with t here and bring them together to find the value of x. So let's go. T minus 1 is equals to t power minus 2x. Okay, something is common. We cancel this. I have minus 1 is equals to minus 2x. Because I'm looking for the value of x, I divide both sides by the coefficient of x, which is minus 2. Okay, I cancel. Then this cancel this. Therefore, my x is equals to what? 1 over 2. Okay, now remember I have gotten the value of what? Of x. Okay, so the next thing I'm going to do is to find the value of y. I can decide to use m raised to the power of 0 is equals to m raised to the power of what? S plus what? Y. Is that okay? Alright, so this cancels this. I have 0 is equals to s plus what? Y. Since I already have my x to be 1 over 2, I'll put it here. So 0 is equals to 1 over 2 plus y. Then it goes over to the other side to be minus. So minus 1 over 2 is equals to what? Y. Now we can choose not to proceed further because we're looking for the relationship between this equation, and we have already gotten our x and our y. Is that okay? Then I will recall from indices that if a raised to the power of half is the same thing as what? Root of what? A. Do you agree with me? Then if a raised to the power of minus half is the same thing as what? 1 over root of what? A. Is that okay? So if we have that notion, we can use it to form an equation connecting that. Okay? So what we are going to do now is to say that this equation V is equals to kt, okay, the x that we already have is half, then dot my mu, the y is what? Minus half. Do you get this now? So what do? We can now say V is equals to k root of what? T times 1 over what? Root of mu. Is that okay? Then we have that, we can say again that V is equals to k, this will times this over 1, this will times, we have what? Root T over root mu. Okay, therefore the equation connecting this says that what? K is equals to root of T over mu. So this is the equation connecting that which we have on the board. Okay, so if you have problem on dimensional analysis, the first thing you are going to do is to know what those symbols stands for. For example, if you are given tension is a force, or weight is a force. If you know that and know the unit of force, you can also get the dimension of force. Is that okay? Then when you get the dimension of force, then you can relate them together and use your indices to bring them together to add the powers and find the unknown and get the constant, and also get the relationship connecting them. I hope this video was helpful. Please, if you are joining us for the first time, just click on the subscribe button for more educative videos. See you next time in my next class. Bye.